Hello students, today we are going to study next aspect of this topic. In that, first is chemical properties of amines. So today's point of discussion is chemical properties of amines. So what is the meaning of chemical properties? Chemical properties means chemical reactions of chemical reactions of amines. In that, first we are going to study laboratory test for amines. First one is laboratory test for amines. Just like aldehydes and alcohols, we have to carry out laboratory test for amines. Laboratory test for amines. Okay, so the first test is litmus test. The first test is litmus test. Means in case of base, take the given compound and dip the red litmus into that compound. If red litmus changes to blue, that compound is basic in nature. So for amines, suppose amines are given in this beaker. Okay, so amines are taken in this beaker and we dip a red litmus paper into it. We dip a red litmus paper into it. Okay, so this is the smallest piece of a red litmus paper. Smallest piece of a red litmus paper. If that red litmus paper changes into blue, that portion changes into blue, it is known as the given compound is basic in nature. The given compound is basic in nature. So this is the primary test for detection of base. Test for detection of base. Now second test is if our compound is base, it should react with acid such as HCl, Okay, so let us consider R bond NH2, R bond NH2. So R bond NH2 means primary amine. If primary amine is base, it should react with mineral acid such as HCl, mineral acid such as HCl. Okay, now hydrogen and chlorine, there is presence of one single bond between hydrogen and chlorine. Okay, so nitrogen carries lone pair of electron, this chlorine carries delta minus and hydrogen carries delta plus charge. So the lone pair on nitrogen attacks on hydrogen. Okay, so what is the product in this reaction? In this reaction, R bond NH3 is formed. R bond NH3 is formed. This nitrogen carries positive charge. This nitrogen carries positive charge. Okay. Plus Cl minus Cl minus. Okay. So HCl is aqueous. R bond NH3 ammonium ion. This is also aqueous and Cl minus is also aqueous. Okay. So this is known as ammonium ion. This is known as ammonium ion. Okay. So when this ammonium ion means R bond NH3 plus R bond NH3 plus again reacts with NaOH. Again reacts with NaOH. R bond NH3 plus Cl minus reacts with NaOH. So NaOH is base, aqueous NaOH is taken and NaOH is taken in excess quantity. NaOH is taken in excess quantity. So what happens in this reaction? In this reaction, this Na and this Cl combines with each other and NaCl is formed as byproduct. Also this NaOH is base means it gives OH minus ions. That OH minus grabs one of the hydrogen from NH3. So OH minus and H plus means H2O is formed. So the products are R bond NH2, nitrogen with lone pair, plus NaCl plus H2O plus NaCl plus H2O. Okay, so this is the detection of amines or detection of basic nature of amines. Means amines are basic, so they react with acid to give salt. So actually this may be also written like this: R bond NH3 plus Cl minus. This is also right. This is known as ammonium chloride. This is known as ammonium chloride. So this is also a detection test for amines. Detection test for amines. Okay. So there is one more test. That test is known as orange dye test. That test is known as orange dye test. Okay. So what is orange dye test? Let us study the orange dye test. In orange dye test, in a sample of aromatic primary amine, means we have to take aromatic primary amine. So first requirement is aromatic primary amine. So what is the meaning of aromatic primary amine? Aromatic primary amine means our NH2 functional group is attached to aromatic ring, is attached to aromatic ring. Okay, so example is aniline. Aniline means NH2 is attached to the benzene ring. So aromatic primary amine, in that aromatic primary amine we have to add 1 to 2 ml of concentrated HCl. Okay, 1 to 2 ml of concentrated HCl. 1 to 2 ml of concentrated HCl. Okay, and plus we have to add aqueous solution of NaNO2. Okay, aqueous solution of NaNO2. So this aqueous solution of NaNO2 is added with cooling, is added with cooling. Okay, so after this addition, the formed mixture or the formed compound is transferred into a test tube, is transferred into a test tube, and that test tube contains beta naphthol in NaOH. That test tube contains beta naphthol in NaOH. Okay, so what is the meaning of beta naphthol in NaOH? Means beta naphthol is one compound which is prepared in NaOH, which is prepared in NaOH. Okay, then we get orange color dye, we get orange color dye. Okay, so after this orange colored dye is formed as the product. Okay, so formation of orange dye indicates the compound is amine, the compound is amine, or the compound is basic in nature. So in this reaction we have to take aromatic primary amine, aromatic primary amine. So aromatic primary amine means just like this. This is aromatic ring. To this aromatic ring, NH2 is attached. NH2 is attached. So this is aniline aromatic primary amine. Plus in this reaction mixture or in this reactant, we have to add 1 to 2 ml of concentrated HCl. 1 to 2 ml of concentrated HCl plus NaNO2. Means here HCl plus NaNO2 is required. HCl plus NaNO2 is required. Okay, and the formed product in this reaction is added in beta naphthol, is added in beta naphthol in NaOH. Then we get orange colored dye, we get orange colored dye. Actually this reaction is for our syllabus. Actually this reaction, for this reaction we have to wait for our next lecture, because in our next lecture this reaction is included in that lecture. Okay, so just keep in mind aromatic primary amine plus concentrated HCl plus NaNO2, and the formed mixture, the formed product is added in beta naphthol in NaOH. It gives orange colored dye, it gives orange colored dye. Okay, so presence of orange dye indicates detection test for amine, detection test for amine. Okay, so these are the three basic tests for amines. These are the three basic tests for amine. So in chemical properties, next reaction is alkylation of amines. Alkylation of amines. Okay, so it is also known as Hopman's exhaustive alkylation. Hopman's exhaustive alkylation. So in this point or in this reaction, alkylation of amines means alkyl group is introduced to amines. Alkyl group is introduced to amines. So amines means R bond NH2. Amines means R bond NH2. Also, this nitrogen carries lone pair of electron. When primary amine, this is primary amine. Okay, this is primary amine. This primary amine reacts with alkyl halide. Reacts with alkyl halide. Alkyl halide means R bond X. This X carries delta minus, R carries delta plus. So this lone pair of electron attacks on alkyl group, attacks on alkyl group, and one of the hydrogen from this NH2 is removed. That hydrogen and this halogen forms the byproduct HX, forms the byproduct HX. Okay, so I write the byproduct here. So the major product is R bond NH bond R, R bond NH bond R. It is also written as R2NH. It is also written as R2NH. Okay, so again, this is secondary amine is formed. This is nothing but secondary amine. So this secondary amine again reacts with one more molecule of alkyl halide, one more molecule of alkyl halide by using the lone pair on nitrogen atom, lone pair on nitrogen atom. Again, this hydrogen and this halogen gives the byproduct HX, gives the byproduct HX, and tertiary amine is formed. So tertiary amine means R3N, R3N. Again, this nitrogen carries lone pair of electron, lone pair of electron. So this is known as tertiary amine. This is known as tertiary amine. This tertiary amine R3N again reacts with one more molecule of alkyl halide, one more molecule of alkyl halide. This nitrogen carries lone pair of electrons. This lone pair attacks on alkyl group, attacks on alkyl group. So here hydrogen atom is absent, so there is no possibility of formation of HX. So what is formed here? Here now total alkyl group becomes 4, R4N, and in this case, due to absence of hydrogen atom, nitrogen has to form 4 bonds. So due to 4 bonds, nitrogen carries positive charge, and in the vicinity of that positive charge, X minus is situated. X minus is situated. Okay, so this is known as tetra alkyl ammonium halide. Tetra alkyl ammonium halide. This is tetra alkyl ammonium halide. Okay, so in this reaction, primary amine gets converted into secondary amine. Secondary amine also gets converted into tertiary. Tertiary gets converted into tetra alkyl ammonium halide. Tetra alkyl ammonium halide. So in this reaction, mixture of products is formed. In this reaction, mixture of products is formed. Okay, so now let us take one example for this reaction. So in the place of R bond NH2, we have to take simple example such as CS3NH2, CS3NH2. Okay. So I will take the example of alkyl halide is CS3NH2. So CH3 bond NH2. This CH3 bond NH2 means methanamine, methanamine, and this methanamine is primary amine. This nitrogen carries lone pair of electron. This methanamine reacts with CH3I. So CH3I means methyl iodide. In this case, iodine carries delta minus, carbon carries delta plus. So this lone pair attacks on this carbon. Lone pair attacks on this carbon. So what happens in this reaction? In this reaction, this hydrogen and this iodine gives byproduct HI. Byproduct HI. And the major product is CH3 bond NH bond CH3 lone pair on nitrogen, and byproduct is HI. So this is nothing but secondary amine, and name of this amine is N-methyl methanamine. N-methyl methanamine. So this is the IUPAC name for the above compound. This is secondary amine. This secondary amine again reacts with one more molecule of methyl iodide. Okay, so here CS3 NH bond CS3 plus CH3I plus CH3I. Okay, so again this nitrogen carries lone pair of electron. This iodine is delta minus, carbon is delta plus. So nitrogen attacks on alkyl group. So in this step, one more alkyl group is added to or attached to the nitrogen, and hydrogen from this NH and iodine from this alkyl iodide are formed a byproduct known as hydrogen iodide. So HI is again byproduct. So major product is CH3N, CH3, also here one more CH3 plus HI, plus HI means also nitrogen carries lone pair of electrons. This is known as tertiary amine, tertiary amine, and name of this tertiary amine is NN dimethyl methanamine. NN dimethyl methanamine. This is IUPAC name. Okay, so this is N-methyl methanamine reacts with methyl iodide to give NN dimethyl methanamine. Again, this NN dimethyl methanamine reacts with one more molecule of methyl iodide. So what happens here? CS3 N bond CS3 bond CS3 lone pair plus CS3I plus CS3I. Okay, so this lone pair again attacks on this alkyl group, but here hydrogen atom is absent. So possibility of formation of HI is ruled out because due to the absence of hydrogen atom, due to the absence of hydrogen atom. So what is here formed? CH3 bond N bond CH3 bond CH3 bond CH3 means nitrogen gets attached to 4 alkyl groups. So nitrogen carries positive charge, and in the vicinity of that positive charge iodine atom is situated. So this is known as tetramethyl ammonium iodide. Tetramethyl ammonium iodide. Tetramethyl ammonium iodide. This is the final product. So this reaction gives mixture of products. This reaction gives mixture of products. So primary amine gives secondary amine gives tertiary amine, and tertiary amine gives quaternary ammonium salt, quaternary ammonium salt. Okay, so this is the first reaction named as alkylation of amines. Means in this reaction NH2 is our functional group, means NH2 is the functional group for amine. From that NH2, hydrogen atoms are replaced by alkyl group. It is known as alkylation. It is known as alkylation. So very simple reaction, very simple to remember and very simple to write. Okay, so this reaction is liked by all students. Alkylation of amine is quite interesting reaction. Now let us move towards next reaction. Sorry. This reaction is known as Hopman elimination. So second reaction is Hopman elimination reaction. Hopman elimination reaction. Okay, so elimination reaction means something is going to eliminate from the reactant. Something is going to eliminate from the reactant. Okay, so in 11th standard or in also 10th standard we have studied types of reactions: addition reaction, substitution reaction, elimination reaction, rearrangement reaction. So elimination reaction means smallest part of the reactant is eliminated. Smallest part of the reactant is eliminated. This is known as elimination reaction. So in Hopman's elimination reaction, reactant is tetra-alkyl ammonium ion. Tetra-alkyl ammonium ion. So let us take here one example, and let me explain the reaction by taking one simple example. So example is CH3, CH2, CH2, N, CH2, CH3, CH2, CH3. Here is also CH2, CH3. Okay. So nitrogen is attached to 1, 2, 3 and 4 alkyl groups. Total 4 alkyl groups attached to the nitrogen. So consider this ethyl, and this ethyl. So three ethyl groups are considered as substituents, and these three carbons are considered as parent alkane. So the name is N N N triethyl. N triethyl. What is the meaning of N triethyl? Means triethyl. Three ethyl groups are attached to the nitrogen. So three groups are attached to the nitrogen. So N is repeated for three times. Ethyl group, three means tri. So N triethyl. So this is parent alkane. So in that chain of parent alkane, three carbon atoms are present. So it is known as propanamine. But this nitrogen carries positive charge. And outside the bracket, I minus is placed. Okay. So this is converted into propyl ammonium. So name is propyl ammonium, and I minus means iodide. So this is the name for this compound. So this is the reactant in Hopman elimination reaction. So reactant is a little bit bulky, means name is complicated, structure is also complicated, but reaction is very simple. So let us try to understand how this reaction is simple. So this N triethyl propyl ammonium iodide is reacted with silver hydroxide and we know that silver hydroxide is less stable, and it is prepared by moist Ag2O means silver oxide dipped in water acts as AgOH. So moist silver oxide is used for production of AgOH. Now this Ag is metal and I is non-metal. So from this bulky giant molecule or giant ion, I minus is replaced. I minus is replaced by OH. Okay. So just iodine I minus is replaced from this position by OH, and Ag and A combines to each other to give silver iodide. So that one is byproduct. Neglect that byproduct. So the major product is CH3, CH2, CH2N. Here CH2, CH3. Here CH2, CH3. Here also CH2, CH3. And outside the bracket, now this bracket is extended. Okay, so outside the bracket OH minus is present. OH minus is present. So what is the name of this complex? NNN triethyl, NNN triethyl propyl ammonium hydroxide. Means just replace iodide by hydroxide, iodide by hydroxide. Okay, so this is the first step of this reaction, first step of this reaction. Now on the second step, on heating, on heating, water is eliminated. On heating, water is eliminated means minus H2O. So minus H2O means this OH minus grabs one of the hydrogen atom from this methyl group. Means OH minus catches one hydrogen from here and gets converted into H2O. So what happens here? CH2 is remaining and this carbon now carries negative charge because hydrogen left this position by releasing electrons to carbon, by releasing electrons to carbon. So here CH2 is formed. This bond is ruptured and electrons are given to nitrogen, and this CH2 is released from this molecule. So CH2 bond CH2. Here valency of carbon is 3. So double bond is formed in between these carbons. So the name of product is ethene. So ethene is eliminated. Ethene is eliminated. So remaining molecule as it is. Rest of the molecule remains as it is. So CH3, CH2, CH2, N, CH2, CH3. Here also CH2, CH3. So only ethene is removed or ethene is eliminated. So this reaction is known as Hopman elimination. Hopman elimination. So this reaction is also very simple reaction, but structure is little bit complicated. Structure is little bit complicated, but we have to रिमाइंड द स्ट्रक्चर. वी हॅव टू रिमाइंड द स्ट्रक्चर. म्हणजे ह्या रिॲक्शन मध्ये काय बघा, रिॲक्शन खूपच सोपी आहे पण स्ट्रक्चर थोडंसं कॉम्प्लिकेटेड आहे. मग लक्षात कसं ठेवायचं, तर पहिल्यांदा एक नायट्रोजन काढायचा, त्याला हे 3 इथाइल ग्रुप काढायचे आणि इकडे काय करायचं, प्रोपाइल ग्रुप अटॅच करायचा. इकडे काय करायचा, प्रोपाइल ग्रुप अटॅच करायचा. ओके, बाहेर कोण असणार आहे, आयोडाईड. बाहेर कोण असणार आहे, आयोडाईड आय मायनस. ओके, सो फर्स्ट काय होणार आहे, हा एन 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 का म्हटलं बघा, तर हा एक इथाइल ग्रुप आहे, हा दुसरा इथाइल ग्रुप आहे, हा तिसरा इथाइल ग्रुप आहे. हे 3 इथाइल ग्रुप कुणाला अटॅच झालेले आहेत, नायट्रोजनला. म्हणून काय म्हटलं, एन 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 ट्राय इथाइल, एन 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 ट्राय इथाइल. इथं ह्या चेन मध्ये किती कार्बन आहेत, 3 आहेत. म्हणून काय म्हटलं, प्रोपाइल अमोनियम. म्हणून याला काय म्हटलेलं आहे, प्रोपाइल अमोनियम. बाहेर काय आहे, आय मायनस. म्हणून याला काय म्हटलं आपण, आयोडाईड. म्हणून याला काय म्हटलेलं आहे, आयोडाईड. एन 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 ट्राय इथाइल प्रोपाइल अमोनियम आयोडाईड. प्रोपाइल अमोनियम आयोडाईड. हा ज्यावेळी AgOH बरोबर रिॲक्ट होणार आहे, Ag मेटल आहे, आय नॉन मेटल आहे, काय तयार होणार आहे, AgI. काय तयार होणार आहे, AgI. आणि ह्या आयच्या ठिकाणी कोण गेलेला आहे, हा OH. मग याचं नेम काय असणार आहे, NNN ट्राय इथाइल प्रोपाइल अमोनियम हायड्रॉक्साइड. ओके, ऑन हीटिंग it loses ethene. On heating it loses ethene. This reaction is also known as beta elimination. This reaction is also known as beta elimination because this nitrogen is functional group. This carbon is alpha carbon and this carbon is beta carbon, and from this beta carbon hydrogen is lost. Hydrogen is lost. So it is known as beta elimination. It is known as beta elimination. Okay. So this is the Hopman elimination reaction. Hopman elimination reaction. Okay. So now we have to move towards the next type of reaction. Next type of reaction. That reaction is known as acylation of amines. So reaction number third, acylation of amines. Okay, so first reaction is alkylation of amines. For alkylation, we take R bond X, means alkyl halide. But for acylation, we have to take acyl chloride. We have to take acyl chloride. Okay, so C2H5 bond NH2, C2H5 bond NH2. Name of this compound is ethanamine. Name of this compound is ethanamine. So this ethanamine is primary amine. So this ethanamine reacts with acyl chloride. Acyl chloride means cs3 c double bond o cl, cs3 c double bond o cl. So this chlorine carries delta minus, carbon carries delta plus. So this lone pair now attacks on this carbon and carbon chlorine bond is ruptured. So one of the hydrogen from NH2 and this chlorine combines to each other to give HCl. So HCl is the byproduct. HCl is the byproduct. Okay, and reaction takes place in presence of base pyridine. In presence of base pyridine. So I will write here HCl as byproduct. Now major product. Major product is C2H5 bond NH. So initially NH2 was present, but now one hydrogen is replaced. So remaining is NH. So here nitrogen gets attached to C double bond O, means carbonyl, and that carbonyl also loses chlorine atom. Okay, so this is the formed compound. Now this compound is known as amide. This compound is known as amide because here CONH is the functional group. CONH is the functional group. Okay, it is known as substituted amine. It is known as substituted amine, and substitution is ethyl group. Substitution is ethyl group. That ethyl group is attached to nitrogen. So N-ethyl is substituent. N-ethyl is substituent. This contains total 2 carbon atoms. So name is N-ethyl ethanamide. N-ethyl ethanamide. This is the name of IUPAC name of this amide. Okay. Now one example for your homework. Just you try for this example. CS3 NH bond C6H5, nitrogen carries lone pair of electrons plus CS3 C double bond O Cl. So this example is for homework. Try for it and find out the correct answer. Find out the correct answer. Okay.